Let's look at problems that involve permutations. There'll be many different types, so we'll just take them one type at a time. Example 3 there says how many 4-digit numbers can be formed using the digits 3, 4, 6, and 7. Okay, so we are given these 4 digits 3, 4, 6, and 7. And we must form 4-digit numbers. So there are 4 positions to be taken up because we need to form a 4-digit number. Each digit should be used once. If you read carefully, it says each digit should be used once, so we can't repeat a digit. Now, in the first position, we can use any of those 4. And so we have 4 different ways of filling up the first position. Now that the first position is filled up, it obviously means we have 3 numbers, or rather 3 digits left. And so the second position can be taken up by any of those 3 that are left. So that will be 3. Now we have 2 digits left, and the third position can be taken up by any of those 2. And now we have only 1 place left and 1 digit, and so that is only 1. Now to get your answer, obviously these numbers should be multiplied by each other. And please take note, this is what we mean by 4 factorial. And simplify 4 factorial, you should get 24. Question B. We are still forming 4-digit numbers, so we still have our 4 different positions to be filled up. And we are using the same digits, which are 3, 4, 6, and 7. This time we need our number to be odd. That is important. And also important is that we can actually repeat our digits in this case. Now for a number to be odd, the digit in the units should be odd. So how many odd numbers do we have? Obviously 3 is an odd number and 7 is an odd number. And that tells us that the last position, the unit position, can actually be occupied in 2 different ways. All right, so 2 different ways. Either a 3 can go there or a 7 can go there because we need our number to be odd. Now, repetitions are allowed, which means even the number that took the unit position can be used again. So how many numbers do we still have to use? I mean, how many numbers are still there within our reach to use? You will notice then that we still have 4 numbers that we can use. And so out of those 4, we need to fill up these positions. The first position can obviously be filled up in 4 different ways. Now, after filling up this position, remember the digits can be reused. Now, this means we still have 4 numbers to choose from. So to fill the next position, we have 4 different ways of doing that. After filling up that position, we still have 4 digits that are left. And so to fill up the third position, we have 4. Now we need to multiply these numbers in order to get our answer. That is where your answer 128 comes from. In C, we want our number to be greater than 4,000. So the number should be greater than 4,000. And the digits can be repeated. We are using the same digits. Remember, our digits are 3, 4, 6, and 7. So we are still using those digits, and we are forming a 4-digit number. So we have 4 different spaces to be filled up. Now we need our number to be greater than 4,000. Clearly that tells you that you can't start with a 3, otherwise your number will not be greater than 4,000. So in how many ways, therefore, can we fill up the first position? It has to be, we can use any number, any of the digits 4, 6, and 7. So there should be 3 ways to fill up the first position. Now the digits can be repeated. That is what the question says. So even after filling up the first position, you still have all the 4 numbers to use. So to fill up the second position, it can be any one of the 4. So there's 4 different ways. And after filling up that position, you still have 4 digits left. And so you can fill this one up in 4 different ways. And you still have 4 digits left. And so you can fill that one up in 4 different ways. Then multiply these numbers and you will get your answer. And that answer should be 192. Right, for the last one there, D, we're looking for a 4-digit number. And we are forming this number using the digits 3, 4, 6, 7. Then it says the number should be less than 4,000. Right, less than 4,000. A number that is less than 4,000, from these digits, we'll have to start with a 3 and no other digit. So we have only one way of filling up the first position. We can only use a 3. And it says the digits cannot be repeated. So 3 cannot be used again. All right. But the number, obviously the number will be less than 4,000 now. Now we can't repeat our digits. So we therefore have 3 digits left. And that means from those 3, we can pick any one of those numbers to fill up the second position. And so this position can be filled up in 3 different ways. Now we can't repeat the digits, so this means we now are left with 2 digits. And so the third position can be filled up using any of the 2 digits that are remaining. So that is 2 different ways to fill up the third position. And we have only 1 digit left, which means the third position, rather the fourth position, can only be filled up in 1 way. Now you multiply these numbers, you will get your answer to that question. Here is another example. We are given 7 boys who sit on a bench in the school hall to listen to a talk. 2 of the boys always talk when they sit next to each other, and so they must not sit next to each other. So the prefect must make sure that these 2 do not sit next to each other. We want to know in how many ways these boys can be seated. Right, so there are 7 boys altogether. 2 of them are a problem. Let's call these 2 X and Y, just for argument's sake. So person X and person Y talk too much. They shouldn't be sitting next to each other. Altogether, there are 7 boys, which means we have 5 more boys here, because we need to get 7 of them together. Right, so we cannot allow this situation here. We cannot allow X and Y to be sitting next to each other. Please take note, X could be sitting to the left and Y to the right. They are sitting next to each other. Or Y could actually be sitting on the left or to the left, and X is sitting to the right. So they are still sitting next to each other. Right, so we want to find the number of ways in which these 7 boys can be seated. The best approach to such questions will be this one here. You need to look for the arrangements, the number of arrangements in which these 7 boys can be seated, supposing there were no restrictions. So when we say these 2 boys should not sit next to each other, that's a restriction. suppose there was no restriction, suppose there was no problem, then in how many different ways were we actually going to arrange these boys, right? So we look for the number of permutations, supposing there were no restrictions. Then, because we don't want them to sit next to each other, we should then subtract the number of arrangements when these boys are actually sitting next to each other. So we need to subtract the permutations when the boys are sitting next to each other. I want to show you how you do that very quickly. First of all, how many different ways, or in how many different ways can we arrange these boys? Suppose there was no restriction. There are 7 boys, so it's 1, 2, 3, 4, 5, 6, 7. This actually means the first position could be taken up in 7 different ways. The second one is 6, 5, 4, 3, 2, 1. So we could have seated them together in 7 factorial ways. Okay, suppose there was no restriction. Okay, so that is the first part. Now we need to subtract from this the number of arrangements when these boys are actually sitting next to each other. Now this is what we mean. These boys here are sitting next to each other. So we need to imagine that they are one thing. We bunch them together and form one object. So if we now count them as one object, it now means we don't have 7 objects anymore. It's like we don't have 7 boys anymore. Now we have 6, because that will be 1, 2, 3, 4, 5, 6. So now we have 6. So ask yourself, in how many different ways can you arrange 6 different people? So 6 different people, that means there are 6 positions. The first position can be taken in 6 ways. The second one in 5 ways. In other words, the number of ways will actually be 6 factorial, because it's like there are 6. So count this one as 1. Okay, so this is 1 person now. Now this is the second person, 3, 4, 5, 6. Okay, so 6 factorial is the number of ways of arranging those 6 objects. Remember, those 2 boys, we tied them together and we're counting them as 1. Now, the other thing is the 2 boys could be sitting next to each other, but in how many different ways can they sit next to each other? Those 2. Because X could be sitting here and Y sitting there. Or Y could be sitting here and then X is sitting there. So do you see that there are 2 different ways of sitting these 2 boys, which is actually 2 factorial. So we will take this thing and multiply by 2 factorial. So that is going to be our answer there. If you put all that in your calculator, I think you can do that just once. You will get your answer 3,600. Please try to go through this again and see if you can figure out and understand what we're talking about.